All right, to give you all a little background about the group I'm working in, I'm working at IBM Research in Almaden in San Jose, Silicon Valley, and our group is themed around accelerated materials discovery. Our group has AI scientists and mainly synthetic chemists, synthetic polymer chemists, and chemical engineers, and all of us have developed significant programming skills to actually being able to develop technology for the lab of the future. And today I want to go a little bit over continuous and discontinuous experimentation setups for polymer research and high quality data set generations. So as so our group has long-lasting history and expertise in ring opening polymerization of cyclic esters, carbonates, and ethers. And we figured out very fast and that when we go to much more reactive systems and higher active catalysts, that we can't do this in batch anymore because the reaction times are so fast that the reactions actually happen below 1 second. So we needed to implement automated reactors, and we're using syringe pumps because you can control all the parameters very well. We connected them to actually go from homopolymers to block copolymers, and in a publication that we reported via JAX in 2019, we explained how we got to 100 block copolymers with distinct different compositions within 9 minutes only. So you can see here, characterization becomes more and more a bottleneck to actually characterize that many materials in a shorter amount of time than it's currently possible. So we were able to push this limit even further to milliseconds with actually going to even more reactive systems. Besides ring opening polymerizations and Chenkov polymerizations, we were also applying the schematic about using automated reactors for step growth polymerizations, and we're investigating polyurethanes with tailored segmented architectures. So when we approach like a lab of the future system and a synthetic problem in material research, we're always thinking about how we can maximize the use of high throughput experimentation tools. And if we don't have a tool available, we actually think about how we can use the individual items like syringe pumps, junctions, fraction collectors, inflow, inline characterization tools to actually develop something very custom. So, and we want to do this because we have ultimate control over the reaction parameters. It's 100% reproducible, and you can capture all of the data that actually led to the result, from temperature, time, flows, compositions. That's so the you minimize the error that you can make by manually trying to capture all of this data. And of course, it's time and resource efficient, how we as we already heard. So the next question is then how we deal with like setting up the right data infrastructure for these systems. So this is an example for a discontinuous experimentation platform where we use the high-speed single channel pipetter. And so we think about it in a way that for the experimentalist in the lab, for us, it was very convenient to use data sheets like Excel spreadsheets to fill in the data. But we applied a very comprehensive model for this data already, that we capture that, because we want to read these Excel sheets and populate it into databases where we store the experiments with a very comprehensive data model. So there's a lot of things that goes into that, what part of the data should be represented in which way. And for this reason, we like document-based databases because they allow us very flexible data schema design and change of that. We then all in our group know how to write some REST API system to actually share this data with clients or with our collaborators within the team who are working on greenfield technologies within AI to actually tackle problems with the chemistry that weren't solved yet. So, and then this loop goes back to the experimentalist, who then gets back the predictions and converts them back into these experimentally executable variables. So
1 minute, please.
So in short, we at IBM, we think we have approached a new area, entered a new area within accelerated discovery, where it's now all about the data and developing AI machine learning models. We also think that hybrid cloud has significant advantages based due to the privacy. You can use federated learning, So nobody else, so your data can stay on premise, especially important for industrial clients. We can't read them. The machine learning will only learn the new weights, for example, and then merge them into the higher hierarchy model. So it's all about automation and especially autonomy. So what we think is, and what we are working on is,
if you could wrap it up in a quick few seconds.
Yeah, so building an autonomous experimental platform where you don't have the need for the involvement of the subject matter expert. However, the subject matter expert stays central to actually interacting with a UI platform, which is actually built on captured fundamental data representations. So this is where we think the future will lead to. And then based on task-specific data, you can actually train technical AI agents. And hybrid cloud, as I already pointed out a little bit, you can use way more data sources and also services that you don't need to have developed yourself and on premise. So I think we think this is where the future will go and where we are working on currently.